This is the Caterpillar D11. One of the world's largest, heaviest, and most powerful bulldozers. And right now, it has a massive job to do.
On the darkest week of the year, a light show like no other.
Volcano has erupted in spectacular style for the 6th time since December.
A spectacular and damaging sight in Iceland. Lava flowed into the fishing town of Grindavik, which was evacuated overnight.
Einar is one of 300 workers who helped prevent lava from destroying the town of Grindavik and a power plant supplying heat to over 21,000 homes. In November 2023, after intense seismic activity, the town was evacuated. As underground magma began shifting, Iceland's government contracted construction companies to redirect the potential lava flow. On December 18, 2023, the nearby volcano erupted, spewing rivers of molten rock and sending fiery fountains up to 330 feet into the air. Since that first eruption, there have been 7 more, and scientists warn another could come soon. When lava emerges from fissures, it typically flows downhill along the path of least resistance. If left unimpeded, it can destroy everything in its path, including homes, roads, and utilities.
Today, they are building this main lava barrier higher and higher and higher.
Building earthen barriers and diversion trenches is one of the few proven methods to slow or redirect lava. These barriers don't stop eruptions, but they can change the direction of a flow enough to protect critical areas or delay the impact. Iceland had successfully used this technique before, notably in 1973 during the eruption on Heimaey Island, when engineers used barriers and seawater to protect a harbor. The Grindavik effort followed a similar principle, but with modern equipment. In late 2023, Icelandic civil protection agencies brought in several large machines, including the Caterpillar D11, to the Grindavik area. The goal was to build defensive earth walls and trenches designed to steer lava flows away from residential zones and industrial facilities, such as the Svartsengi geothermal power plant. The D11 and other machines worked around the clock, excavating trenches and piling up soil and rock to create long ridges. Engineers analyzed the local topography and lava flow models to decide where barriers would be most effective. The work had to be done quickly, as eruptions were expected at any time. The Caterpillar D11R isn't just a bulldozer. It's a steel giant. At nearly 30 feet long, it's the same size as a city bus, but way taller, over 15 feet high, like a 2-story building on tracks. And the weight? A jaw-dropping 105 tons. That's 230,000 pounds of raw industrial power. To put it in perspective, it's heavier than 15 full-grown elephants, and even outweighs a fully loaded Boeing 737 at takeoff. The Caterpillar D11R, built between 1996 and 2008, was designed for massive mining and earth-moving projects. Getting the D11 to Iceland wasn't easy. The country's largest construction company, Ístak, used emergency laws to bypass import procedures. The machine was shipped from Norway, disassembled into 3 parts at a cost of roughly 200,000 euros, or $235,000. They needed power, and they needed it fast. They needed the D11. The D11's rear ripper tears through hardened ground, while the blade at the front pushes massive volumes of earth. Its wide tracks distribute weight evenly, allowing it to move without sinking, and the push arms transfer raw power from the engine to the blade. The D11R's blade can push 34 cubic meters, 45 cubic yards, of material, powered by a 915 horsepower engine. Authorities brought in multiple construction companies, tasking them with building earthen walls to divert lava flows. Scientists can roughly predict where and when the next eruption might occur, and based on that, construction teams rush to build new barriers, often on top of still hot lava. The Blue Lagoon, only 3 miles from Grindavik, draws 3,000 visitors a day and is vital to Iceland's tourism and energy sector. Its heat comes from the nearby Svartsengi power plant, which produces both electricity and geothermal heat for thousands of homes. Working near an active volcanic fissure is unlike any other construction site. The heat distorts the air, and the smell of sulfur mixes with diesel exhaust. Ground temperatures can exceed 80 degrees Celsius just a few meters from the flow. Mechanics must constantly check the bulldozers. Metal tracks expand, hydraulic lines overheat, and sensors malfunction from ash and vibration. Every hour of operation in such conditions takes a week's toll on the machines. Still, the crews persist, often working through fog, tremors, and freezing winds, knowing that each trench they build could change the path of an advancing lava flow. When they first brought the machines to the site in November 2023, the ground shook violently. Earthquakes above magnitude 5.0. The 100-ton machine was swaying on the trailer. We thought it might fall. It was terrifying. As project leader, Einar bears not only responsibility for the machines, but for the lives of his crew. On February 8, 2024, lava unexpectedly surged toward their position. Just seconds after a photo was taken, a fast-moving flow forced the team to flee. The bulldozers, including the D11, scrambled uphill, and operators narrowly escaped destruction. Then, on January 14th, tragedy struck. Einar suffered a heart attack in the middle of the night, as a new eruption threatened the town once again. Einar takes pride in his work and the machines he operates. But behind that passion lies constant danger. He and his team have faced perilous situations time and again. In this line of work, the stakes are simple: life or death. That same night, lava cracked through the defenses, moving dangerously close to Grindavik, and to millions of dollars worth of heavy machinery. While Einar lay in the hospital, his team risked their lives to save the dozers. They ran ahead of the lava and managed to get the machines out just in time. Just days earlier, on January 10th, another tragedy occurred. A worker disappeared while filling a massive fissure. Even now, the land around Grindavik continues to sink, in some places by 1.5 meters. We've managed to save the area, but the question is, should we keep trying? The Icelandic government has since bought most of the homes in Grindavik, offering residents financial relief. Officials say the goal is to eventually resell properties and bring people back, but not everyone agrees. Most residents have moved away, starting new lives elsewhere, though some still dream of returning. A recent survey found that nearly half of residents say they're likely to return. Even if Einar has doubts, he keeps trying. Every eruption brings a race against time. When magma starts rising beneath the surface, crews have only a few days, sometimes just hours, to react. Geologists send updated models to the engineers in real time, showing where fissures are likely to open. Bulldozers like the D11 are then dispatched to critical zones marked on maps, where they begin cutting trenches and raising embankments before the first lava appears. Each section of wall is calculated carefully. The angle of the slope, the material density, and even the distance to nearby roads all affect how long a barrier might hold. In such operations, precision matters just as much as power. The land itself constantly changes under their feet. What was once a road may become a crack or sinkhole overnight. Steam vents appear where none existed before, and molten rock pushes upward through thin crusts of cooled lava. Engineers must frequently halt work to reassess terrain safety, and sometimes move entire operations a few hundred meters away. These unpredictable shifts remind everyone involved that they are not conquering nature, only cooperating with it for as long as possible. It's a process of continuous adaptation, a balance between caution and courage. The operation isn't just about saving homes, it's about protecting critical infrastructure, energy, tourism, and livelihoods. Without it, thousands would lose power and heat, and rebuilding would take years. But for Einar, it's about something deeper. Caterpillar D11. This is the world's second largest dozer. It is 35.8 feet long, 10.4 feet wide, and 14.9 feet high. Usually such are the dimensions of a bus, not a dozer, but this dozer is still shorter in size compared to the world's largest dozer, which is the Komatsu D575. It is 40 feet long, 23 feet wide, and 10 feet high. In short, the Komatsu D575 is way larger than the Caterpillar D11. However, mining companies prefer the D11 dozer more. The difference becomes obvious when you look at the sales and production numbers of both machines. The first Cat D11 was introduced in 1986. In 2023, Caterpillar celebrated the 6,000th D11 dozer after its shipment to Australia. On the other hand, there is not much data about the Komatsu D575 production, but according to some reports, only 53 Komatsu D575 dozers are currently operating, 31 in North America, 14 in Australia, and just 8 in Japan. But what makes the D11 dozer more of a favorite in the mining sector? To comprehend this fully, we must examine each of its fundamental components and the technology that contributes to its status as an unrivaled powerhouse. The crawling system. A crawling system is one of the most important features of a dozer. It enables navigation across rough terrain and challenging weather conditions at the mining site. By weight, the D11 is 114.9 US tons. It is even heavier than the M1 Abrams tank. Considering its size and weight, a robust crawling system was needed that can distribute the weight effectively and provide it traction for heavy-duty tasks without compromising the fuel efficiency. The engineers of D11 managed to design an advanced track system. Unlike the conventional track systems found in the D575 and many other machines, the D11 features an elevated sprocket undercarriage. This design isn't just for show. The elevated sprocket setup plays a key role in improving durability and minimizing wear, especially in high abrasion conditions like rocky mines or compacted soil. It reduces what's known as scalloping, which can happen when repeated ground contact wears down track surfaces unevenly. The system itself is made up of robust metallic chains formed by crowned rail links. These links interlock securely using precision-fitted bush locks, ensuring strength and flexibility as the machine moves. Supporting all of this are front and rear idlers, along with lower rollers that help guide the tracks and keep the motion smooth. Meanwhile, the elevated sprocket at the top delivers raw power from the engine, driving the entire track forward. The result is a machine that doesn't just move, it dominates whatever terrain it's on. Many of you may not know that Caterpillar is actually a pioneer in the development of dozer. In fact, the inventions of the founding fathers of this company laid the foundation of a modern dozer. It was the dawn of a new industrial age, an era when steam power and fuel combustion were beginning to reshape the world. Across America, farmers were embracing tractors to plow their fields, but in California's Delta region, they hit a unique challenge: soggy peat soil. Standard tractors would sink and stall, making farming nearly impossible. That's when a man named Benjamin Holt stepped in. With a mind for engineering and a determination to solve real problems, he developed a new type of tracked vehicle that could handle the soft terrain. This innovation not only transformed farming in the region, it laid the foundation for what would become one of the most iconic names in heavy machinery: Caterpillar. Each of Holt's prototype tracks measured 9 feet long and 24 inches wide. They were made of wooden slats, 3 by 4 inches each, bolted onto a continuous chain. The systems spread the machine's weight across a broader surface, supported by rollers and a reinforced frame. The result? A machine that could glide over terrain where others got stuck. Holt's invention was more than just a mechanical upgrade. It was a commercial triumph, and it marked the beginning of tracked machinery as we know it. While Benjamin Holt rightly earned credit for inventing the tracked undercarriage, the iconic dirt-pushing blade, the very thing that turned tractors into bulldozers, came from a different source. In 1923, a farmer named James Cummings and a draftsman named J. Earl McLeod designed the first practical dozer blade attachment for Holt's tractors. Their design was patented 2 years later and would change earth moving forever. That same year, 2 companies, Holt Manufacturing and CL Best Tractor, joined forces to create what we now know as Caterpillar Tractor Company. Early machines from this era, visible in old black and white photographs, show steel workhorses equipped with thick metal blades mounted up front, a symbol of raw power and mechanical ingenuity. Over time, 3 primary blade types became standard in the industry. The S-blade, or straight blade, is the most basic. It's short, lacks side wings, and is designed for precise tasks like fine grading and handling broken or granular materials like soil, sand, and gravel. Usually, only small and medium-sized dozers are equipped with the S-blades. The U-blade, or universal blade, features high curvature and large side wings. It can move a large volume of material, ideal for softer soils and tasks like ditching, hauling, and crowning. The SU blade, a hybrid of the two, offers a balance between penetration and capacity. With moderate curvature and smaller wings, it's suited for pushing medium-density soils and handling longer-distance grading, stumping, and ditching work. There are various blade options for the D11 dozer. It can be equipped with a 35.6 cubic yard semi-universal blade or a massive 57 cubic yard U-blade. The D11 features a 29.3-degree interior angle between the back bottom of the blade and the ground. This clearance angle allows the blade to better penetrate and load. Caterpillar also offers blades with the ability to resist torsional bending and distortion and offer increased wear resistance without sacrificing machine balance or performance. One of the key features found on today's dozers is dual tilt blade technology. This allows operators to angle the blade forward or backward, depending on the task, whether they're cutting into tough material, carrying it, or spreading it across a surface. But constantly adjusting blade angles can become physically demanding, especially over long shifts. That's why Caterpillar equipped the D11 with automated blade assist. This smart feature allows operators to preset blade angles for different parts of the work cycle. With the push of a button, they can instantly tilt the blade for cutting, transporting, or dumping, without needing to manually adjust it each time. The result? Less fatigue, more consistency, and a smoother workflow. For those looking to take precision to the next level, Caterpillar also offers an optional 3D grade control system. This advanced system uses dual GNSS, Global Navigation Satellite System antennas, and a network of inertial measurement unit, IMU, sensors to automatically monitor terrain conditions. Based on real-time data, the system adjusts blade lift and tilt with incredible accuracy, turning complex grading tasks into near-automated operations. Whether it's bulk earth moving or fine grading, these intelligent technologies help the D11 work faster, smarter, and with greater precision, making every push more productive than the last. At the heart of every bulldozer is its frame, the backbone that holds everything together. For the Caterpillar D11, that backbone is forged from high-strength cast steel. This isn't just for durability. It's designed to absorb extreme impact forces and twisting stress during heavy-duty operations. Whether it's ripping through rock or pushing tons of earth, the frame ensures the D11 stays solid and stable. The main structural skeleton is built by welding together large steel plates. And this isn't done by hand alone. Caterpillar relies on advanced welding robots equipped with vision systems to measure and monitor each weld with pinpoint accuracy. While these robots handle the bulk of the welding, skilled technicians still step in to perform prep work and tack welds, ensuring strength and precision throughout the build. Once the frame is complete, it moves through an electrostatic painting system. This fully automated process applies Caterpillar's signature yellow coat, creating not just an iconic look, but a protective finish that stands up to harsh conditions. To move massive volumes of soil, rock, or debris, a dozer needs more than brute strength. It needs torque, and plenty of it, delivered consistently throughout its work cycle. That's where the CAT C32 engine comes in. Recognized as one of the most power-dense high-speed diesel engines ever built, it delivers over 840 horsepower and an impressive 4,548 pound-feet of peak torque. This kind of muscle ensures the D11 can handle even the most demanding jobs without missing a beat. But more horsepower also means more fuel consumption, and for large operations, fuel cost is a major part of the bottom line. And that's not all. Traditional diesel powertrains can struggle to respond quickly when a machine suddenly needs more or less energy, causing performance lags and inefficiencies. Powertrain. To solve both issues, Caterpillar introduced a cutting-edge solution, an electric drive powertrain for its top-tier models. The D11XE is the result of this innovation, the most fuel-efficient dozer in its class. Here's how it works. The diesel engine drives a generator, converting mechanical energy into electricity. That power is then managed by a control unit, which sends only the exact amount needed to high-efficiency electric drive motors. This setup allows the engine to run more consistently without constant revving, reducing wear and fuel use. Excess power can even be stored and reused later, boosting overall efficiency. Because electric motors respond far faster than traditional gearboxes, the D11XE experiences virtually no lag. There's no gear shifting, which means smoother operation, greater maneuverability, reduced downtime, and a longer rebuild life. In the end, Caterpillar's approach to the D11's drivetrain isn't just about power, it's about delivering that power efficiently, reliably, and at a lower cost per ton. It's a system built for performance, longevity, and smart economics in the field. As the old saying goes, with great power comes great responsibility. And in the case of the D11, that responsibility is all about safety. With a machine this large and powerful, operator protection isn't optional. It's engineered into every detail. In critical situations, the D11 responds automatically. The engine is designed to shut down instantly in an emergency, while a factory-installed fire suppression system kicks in to extinguish flames within seconds, helping prevent damage and protect lives. The dozer is also surrounded by guardrails, safety sensors, and strategically placed cameras, ensuring constant awareness of the environment. Access to the cab is made safe and efficient with a power ladder that retracts into compact sections when not in use. And once inside, the operator benefits from large windows, extended mirrors, and advanced display screens, all contributing to a full 360-degree view of the surroundings. If the operator leaves the seat, the machine automatically locks the powertrain, reducing the risk of accidental motion. Caterpillar has also integrated its newest innovation, Cat MineStar Object Detection. This smart safety system uses radar to continuously monitor the entire perimeter of the dozer. Whether a hazard is in front, behind, or along either side, the system identifies it in real time and immediately alerts the operator. Highlighted camera views help pinpoint the location of the risk, enhancing decision-making and reaction time on the job site. These features work together to turn the D11 into more than just a powerful tool. It becomes a safe, responsive, and intelligent partner in demanding work environments. Improving a machine that's already ahead of its time is no small feat, yet Caterpillar continues to raise the bar by assembling teams driven by passion, foresight, and a deep commitment to innovation. While boosting productivity remains a constant goal, the modern era demands even more: greater safety for operators and maximum operational efficiency. One of the most groundbreaking advancements is the introduction of remote operator stations, a technology that allows operators to control the D11 wirelessly from a safe distance. Australia's Wolf Group was the first to adopt this system, deploying 6 D11 dozers to a remote mining site. The results? Remarkably consistent performance, and, more importantly, a safer work environment by keeping operators out of harm's way. This shift has changed the operator experience entirely. Instead of enduring long hours inside a vibrating, noisy cab, operators now work from quiet control stations. Early feedback shows that they experience less fatigue, which helps maintain sharper focus and leads to better decision-making over longer shifts. Caterpillar has also introduced semi-autonomous operation for the D11. This cutting-edge system allows one operator to control up to 4 dozers simultaneously in push-to-edge applications. It uses onboard sensors and real-time environmental mapping to respond to terrain changes, making adjustments quickly and efficiently, even handling manual overrides with seamless precision. And this is only the beginning. Caterpillar's long-term vision is to fully automate the D11, transforming it from a powerful tool into a self-sufficient, intelligent machine capable of reshaping the job site, one pass at a time. The D11 isn't just built for power, it's built for scale. That's why it's most commonly found in large-scale mining operations. But with great size comes a serious logistical challenge. How do you move a 250,000-pound machine to a remote worksite? Unlike a Mini Cooper, you can't just load the D11 onto a flatbed and hit the road. Transporting this beast is a carefully planned operation. In most cases, the dozer has to be partially dismantled before it ever leaves the factory. In the United States, one common method is to ship the main body by flat car train while removing the massive blade, push arms, and ripper assembly to reduce the load and stay within legal transport limits. In more complex cases, the D11 is disassembled into several large components, each loaded onto separate trailers. This modular approach makes it easier to navigate highway regulations, weight restrictions, and even narrow or rural access roads. Once on site, specialized crews reassemble the machine piece by piece, bringing it back to life, ready to tackle the toughest jobs on Earth. From the mines of Australia to construction sites across Europe, and back to the farmlands of the United States where its legacy began, the D11 continues to shape the Earth with unmatched precision and raw power. It's not just a machine, it's a global force. In the world of heavy equipment, the D11 remains the uncrowned king of dozers. Thanks for joining us on this deep dive into one of the most iconic machines ever built. We've poured a lot of time and passion into this project, and we're excited to bring you more like it, hopefully on a weekly basis. But we want your input. What machine, process, or invention should we explore next? Drop your ideas in the comments below. Don't forget to like, share, and subscribe if you enjoyed this documentary. Your support helps us keep creating. Thanks again for watching, and we'll see you in the next one.